Okay, the next section is about the effect changing of pressure and temperature, and I'm going to go ahead and do the last section about optimum conditions. So again, this all relates back to Le Chatelier's principle. And so the definition is the change of pressure by increasing the volume, which means it decreases the pressure. The reaction shifts in such a direction of more moles of gas. And so while I know it's kind of hard to see this is 2 moles of A as a reactant to 1 mole of B as a product. And so when I have my initial equilibrium, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 versus 2, 4, 6, 8, 10, okay? When I decrease the volume, which means I increase the pressure, you notice that I go almost all to B because there's 2 moles of gas on this side and 1 mole of gas on this side. So when I increase the pressure, it goes towards B such that I only have 1 A here, okay? When I increase the volume, which by definition then decreases the pressure, you notice that I have a lot more A, so it shifts towards more moles of gas and less. So if I increase the pressure, it shifts towards less moles. If I decrease the pressure, let me start over here. If I increase the pressure, it shifts towards more moles of gas. If I decrease the pressure, it shifts towards more moles of gas. And so you can see here there's a lot more A than there is B. So here would be the question. Indicate which direction would the reaction shift by changing the volume to increase the amount of product. So basically the answer will be, don't worry about the volume, would I increase or decrease the pressure? Okay. And so what I have to look at is this is a gas and that's a gas. I want to make sure I pay attention to the phases. Sometimes it may give you one, it's not. And so this is 3 moles of gas over here and one side over here. I want to produce more of this. That's what increasing the product. So therefore I want to shift it towards less moles of gas. And so therefore I would increase my pressure. And by doing so, I would then produce more of the methanol. Okay, I suggest that you pause it here and do the next one. For this one, it's 3 moles versus 2 moles. So again, I want to shift it towards less moles of gas. So again, I would increase pressure. And the last one, I have 1 mole here versus 2 moles here. So now this one's the opposite. And so this one, I want to decrease pressure. Okay. The second part of this is a temperature change. And here's the way that it's stated in the textbook. And I'm going to show you instead how I think about it when we get to the problem. Okay. For an endothermic, an increase of temperature causes more product. For an exothermic, or negative delta H, an increase of temperature produces more reactants. So here's an image from the internet. Okay, so for endothermic, if I increase T, it goes towards products. If I decrease the T, it goes towards reactants. For exothermic, it's just the opposite. And the way that I think about this instead is I go back to the very first one of adding and removing products. Okay, so for endothermic, it's endothermic because I have to add heat to my reaction. So I'm just going to have a generic reaction here. A plus B in equilibrium goes to form C plus D. I don't even care what the coefficients are. Okay, so endothermic means I have to add heat, or I'm adding heat to this reaction. And so by definition, if I'm adding heat, that means, remember going back to the pot analogy, that means that my heat would be considered to be a reactant because I'm adding it to the pot. These are my ingredients. My reactants are my ingredients. My products are what I take out of the pot, the dinner that's done, the soup is done, whatever it may be, afterwards. So if I think about it this way, now if I add heat, whatever way I add, it shifts away from. So if I add heat, it shifts towards the products. If I remove heat, then it shifts towards what I remove. So if I remove heat, it shifts towards the reactants. And for an exothermic reaction is symbolized by the fact that it gets hot or it gives off heat. So it emits heat. And in that case, I'm going to think of heat as being a product. So I'm going to just choose another set of letters, G plus H, in equilibrium to go to I plus J. Okay, and so again, I'm going to add heat then as a product. It's producing heat, it's emitting heat, however you want to think about it. And again, if I add heat to it, it's going to shift away, which means it's going to go towards the reactants. If I remove heat, then it shifts towards, and therefore will be more products. And so that's the way that I think about this. So now we're going to do a problem. So it says preparing hydrogen by the decomposition of water. So I have two waters as a gas molecule, goes to form hydrogen gas plus oxygen gas. What do you expect the decomposition to be favorable at a high temperature or low temperature? So I look at this, and it doesn't even matter what the value here is, the fact that this is positive. So this is a positive 484. So this is an endothermic reaction. Because this is positive, it's endothermic. So that means that I'm going to add heat as a reactant. And now I want to produce, do I expect the decomposition? Do I expect the products to be more products at a high temperature or a low temperature? Well, I want to add heat in order to shift it towards the products. So the answer is a high temperature. Okay. All right, the next section has to do with choosing optimum conditions and what will yield the most products. That's kind of what we've already been doing it, but now we're going to be looking at multiple things. But before I go to that problem, just the effect of a catalyst. Basically, a catalyst only changes the speed of a reaction. It doesn't change the equilibrium composition, so a catalyst has no effect. And I have been known to ask that question in the past on an exam. So here's one about choosing the temperature and pressure conditions to get more ethane from this. Okay, so to answer the question for temperature, all right, so if delta H is less than 0, is that endothermic or exothermic? Well, if it's less than 0, it has to be negative, so therefore it's exothermic. So that means that my heat is a product. So do I want to add heat or remove heat? I want to remove heat, so therefore it's going to be a low temperature. So that's part A of this question. And do I want high pressure or low pressure? Then, and I look at this, and by that looking at this, I have 2 moles of gas over on this side. I have 1 mole of gas over here. So I want to go towards less moles, and so that would be to have a high pressure. So if I do this reaction at a low temperature but with a high pressure, then I'm going to produce more of the ethane gas. And that's how you do these type of problems. And that's the end of chapter 14.